Hey there, everybody. Robert Taylor with Wonderscape Creations, continuing on with our world building series, specifically with PCG. So, as you recall, by the last episode, we got this transition working to make things look a little nicer. And as you recall, I stated if you wanted to, you could make a bool so that you can choose when that happens. and that bool will be going over in the next episode on how to do that. So, as I stated before, we're going to go over projection and creating the slope. If we have time, we'll also create the debug so that we can actually see what's going on here. Now, there have been a few times that I've said hit A, and you'll see all this information. So let's briefly go over that, because when we do the projection, a lot more information is going to show up. So obviously, you have the normal positions, pitch, the rotations, the scale, the bounds of these boxes, colors. Right now, they're all white. Density, steepness, and seed and distance. Distance we gained from the fall off. So now we're going to do a projection. So first things first, let us right click and type in projection. So I myself have not messed with very many of these, with any of the settings in here. So take that with a grain of salt, that I just utilize it for its strength, which is, as I said, projecting onto the landscape. Let's come down here. It'd be more impressive to see like this. I'm going to right click and type get landscape data. And here we go. And in this node, we can choose what we want to pull. So we're going to want the layer weights. That's important for us to have because of one of the functions that we're going to be using. Then you can only get the height if you want to get the height, things like that. So let's go ahead and place that in here. And obviously, we didn't see any changes yet. But if I go ahead and hit D right here, you're going to see it down, chilling on the ground now. Obviously, now we can delete that. We don't need it. Now, there it is. And no matter what, regardless of if this goes underneath, give it a second. We come over here, open this up, click on that. It's still on the landscape. So we don't have to worry about any of that. So I'm going to bring that back up because I like to see it. All right. So yeah, now that we have everything projecting, we have stuff projecting where it shouldn't. Well, not projecting. We have stuff spawning where it shouldn't. So we're going to go ahead and take care of that. And it's super easy, super quick. For me, yes, we're going to make another subgraph. Like I said, just makes it really easy for people to read, to see what's going on. Right click, PCG, and then of course name it PCG create slope TLCOA. Go ahead and open it up. The slope is actually very simple and straightforward. There isn't going to be a terrible amount that we're going to do in comparison to the last one, which is why I said we might get to the debug stuff. Let's go ahead and put that here. First thing that we're going to want to do is going down. I kept the first pin as it is. So we want, oh, I'm in the out. So let's delete that. There we go. And first things first, we want the slope strength. Make it an attribute set. find it. There we go. And then the rest of them are just simply duplicates. This is not a loop. We don't have to worry about it. The next one is a slope angle. Max slope angle to be specific. Duplicate. And then this one, slope min max. I should actually rename that because I made a change. So yeah, I'm going to change that to slope scale size. Then we have near slope density. All right, huzzah. First thing we want to do is get a new node called normal to density. So this bad boy, actually, let's just go ahead and make this a point. There we go. Sorry. So this point, this bad boy right here, right now, normals are on the Z scale. So that's what's going to stop things from projecting where we don't want them, aka on the rock. But obviously, before any of that works, we have to create a density filter. So if we had this in the world and we were to hit the D, it would show us, you know, things right here would be black and the closer to flat would be white, things like that. Like I said, because it's not directly, you know what, let's do it. Let's just do it. Let's give you guys something to look at. So we're going to come over here, get our create slope, create the subgraph. So let's remove that right there. Go over here, hit D. Let's see here. Let me make sure I set this up correctly. Okay, density filter. Okay. So, come right here. I put you to 0. Obviously, I put you to 0.5. Still nothing's going to happen. 6. Things are starting to slowly disappear. 0.9 is where things get crazy. So obviously we don't want it at 0.9 based off of our material here. So what about 0.8? Look at that. Beautiful. So we know we're going to want it at about 0.8 at some point. 0.75. I'll put you like that for the moment. There we go. Now then, next thing we're going to do is another density filter. Excuse me. Copy, paste, and paste. We want 2 of them. So this first one will be 0.95. This one is also 95. Oh, that's why. This is 0 to 0.95. And this one right here is the 0.95. There we go. Might play with those and change those down the road, but for now we'll keep them as is. Might even find a way to not have them hard-coded, but we'll play with that later. Next, we want a difference node. Obviously, we want binary discrete. Then we're going to come over here to source, and then difference right there. We're going to copy and paste. So we give that along with this right here. And now we're going to want a multiply node. Place that right there. We're going to want to change the input source 1 to scale. And then this 0.2 to near slope scale. That is right here. Slope scale size. I believe that's the right one. Yes. So place that right here. It's just like that. And then before we continue on, since we're right here, come here, strength, the slope strength goes to this strength right here. Which right now it's 0, so it's, pretty flimsy. But that's okay. We'll play with it and show it off in a minute. And then this one, we need the lower bounds. Okay. There we go. And then out of this bottom difference, we're going to pull out and do attribute noise. And then from the last, we're going to change it to density. And obviously get a density filter. And then we are going to change the lower bounds to that one. Just like that. Now, out of this multiply right here, we're going to get another difference node. Obviously, binary discrete. Place that in here. And we'll come right here. Oh, that's right. Need to open that. Place you there. And there. There we go. So with that, we have this set up. But obviously nothing has changed. And that's because we need to go back into the assigned data. We need to fill this up. So here's where things get fun. Excuse me, because now we'll be using all of these right here. So what we currently need is the slope info. So named want to name one. F2, we will name it slope info. I'm going to need params and then slope info. We need both of these here. And we would need to get an attribute filter. Now then, we place params, ooh, that was close, in the bottom, and slope goes on the top. Now this is where ID comes in. ID and ID. There we go, it's all gone. Now if we hit A, there we go, ID. 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 So you get what I'm saying. We now have the ID. And it's important for us to have the ID because we want to make sure that the IDs match for when we pull specific attributes. So again, the strangely named node called delete attributes and make it keep attribute. We only want what's inside the filter, and it needs to be named slope strength. So obviously, if we come back over here, we got that right there, slope strength. We'll deal with that in a second. For some reason, that pops up out of nowhere when it shouldn't at this point. Anyways, let us continue on here. Then we need 4 more. Copy, paste, paste, paste. And in. Memory's getting high, so we'll need to restart this in a moment. PCG tends to slow down because the longer you have a project open, the more memory it takes. So after I get this set up, I will restart it. Next thing you want is the max slope, which we can see here in the A is called max slope angle. And then we want the slope scale size, which is near slope scale. And then the last one is near slope density. We'll place that right there. All right, Control save. Let me pause and restart the project real quick, and the error should be gone. All right, so it didn't go away, and I know why. Come back over here. We have the slope scale, near slope scale. Copy. We come over here. They're the exact same. I am unsure why. Mismatch between the number of elements from pin in A, pin in B. This is quite interesting. Let's multiply the source. We need to be scale. All right, I need to see what I did wrong here, because it should be working, and it's not. So I will be right back. Silly me. All right, as you can see, the error is now gone. When you go back to the attribute filter, I forgot to change the operator to equal. So now that that's been solved, as you can see, everything is looking quite lovely and quite beautiful. And it is all unique to the data type. So if I come over here and come over here, which one? I'll do the small ones because we know they'll happen. And go to slope. Scroll on in here. And right now it's set to 0.9. If I change to 0.8, it only did it to the tiny stuff, left everything else how it was. So we can thin things out as we get to the slope. Now, since we do have time, we're going to go ahead and get the debug color working so that we can tell what is what, essentially. So it's actually really quite simple. So the first thing we're going to want to do is get a branch node. First, let's remove the debug. We don't want to see that. Well, we do, but in a bit. And now we're going to come back to the biome spline here. So I don't think, yeah, we don't have it attached yet. So if we create another one of these, get property from object paths, and we name this one debug. Yes, okay, it was named debug, good. And we plug that in, let's save. Back over here to the front where we see landscape bool. Oh, no, not that. Silly me. Don't need to do that. Right click, debug. I forgot for this instance, I created a named reroute called, I thought I did. Let's come over to grab settings. Yeah, it's right here. Get debug. There we go. Place the output to be right there. So we'll delete that for a moment. What we're going to want to do is get the params reroute node here and get another one of those amazing delete attributes node. And this one, obviously, we want to keep. And it's going to be the debug color. I'll pull out a B and type copy attribute. And we'll place the attribute in there. And input source, we will go to last attribute. So it's going to get this one. Then the output source is going to be color. Perfect. Now with that said, come over here, right click and type debug. Just like that. Hit save. Obviously nothing has currently happened. However, we select debug. Nothing happens. I did that on purpose. I want you to see it. Now let's go back to the debug. Click on this right here on the debug icon. And we need to go to the material override. And we need to type PCG underscore debug material color. Bam. Look at all that color. And now we'll be able to know what's causing what problems. That's everything we're going to go over in this episode. In the next one, we will go ahead and get the height taken care of. And then we have a few fun things to go over with the landscape and the one after that. So yeah, thank you so much for watching, and I hope to see you guys in the next episode.